right. Morning, morning. So today we're going to look at some steps for conversions. Follow this verbatim. Follow it step by step. The speed will come. So I know that a lot of students are looking for a fast way or an easy way. I'm pretty lazy. I think I've pretty much found the fastest, most efficient way to do chemistry and still get it right. I mean, there's easier ways to do this and faster ways, but I can't guarantee that you're going to get it right. But this is probably the fastest and easiest way I know that you can do chemistry and still get it correct. I know that a lot of you guys are really, really smart, really, really bright. So if you have some other ideas on how to do it faster and be efficient, just let me know in the comments. All right, so let's take a look at the steps. These are the steps I used. I've broken it down to 5 steps. Chemistry is can be challenging at times, so I took the science out, and now we're just, this is just about effort. This is just more at elementary school level. So step number one, we're going to write our given and unknown information. So that just allows it to convert the problem, like a word problem in English, to the language of chemistry and science. So English language arts is good for over there. In science, we just want the nitty gritty. That's it. Step number two, rewrite my given and draw a T-chart. So rewriting given, that's just matching from elementary school. T-chart, ABCs, 1, 2, 3, elementary school. No chemistry yet. This is all about effort. This is just, hey, did I make an effort? Step number three, fill in units. Given units on top, unknown units on bottom. It's effort. No chemistry yet, no science yet, just matching. ABCs, 1, 2, 3s. Can I do matching? Yeah, that's elementary school stuff. All right, step four, fill in numerical values. Again, that's matching. That's not chemistry. That's not science. Step number five, execute math operations. This is probably going to be algebra. So, you know, 5th grade, 6th grade math, not high school math. Nothing difficult here. This is easy. This is too easy. All right, let's put these steps in motion. Everybody ready? Okay, let's go. All right, so how many moles in 70 grams of chlorine? So now I'm just going to go through the steps. So step number one is write the given and unknown information. A lot of people want to skip this step. I'm telling you now, don't do it. We'll be in tutorial a lot of times, and we don't want to spend or waste time. It's easier if you just write the given and unknown as opposed to coming to tutorial and like, hey, write your given and the unknown. All right, so write the given and the unknown information. How many moles in 70 grams? So they're asking me to find 70 grams of chlorine is the given information. And then the unknown information they're wanting me to find is moles. All right. So anytime we're going from moles to grams of the same thing, we need to use molar mass. So let's go to our periodic table, look at chlorine. Chlorine is over here. This is 35.5. And we're just going to call it 35 today just for the sake of simplicity. 35. We'll just call it 35. Right? All right. So I have an equation. So I know that for every 1 mole of chlorine, that's going to be equal to 35 grams of chlorine. I can also write this as a ratio. So this is an equality. Equality can be written as a ratio. 1 mole of chlorine, 35 grams of chlorine. So this is just an equality. You can write an equality like this with an equal sign, or you can write it as a ratio. All right. So let's go back to step number one. So step number one says write given and unknown information. We have step one. I pulled out some information that we needed to do the conversion. Step number two, rewrite given and draw your T-chart. All right, so my given is here. I'm just going to rewrite it. This isn't science. This is just matching. So a T-chart is just a capital T, and then he fell over on his left. So capital T, fall over to your left. All right, so 70 grams of chlorine and a T-chart. So I rewrote my given information, and I drew a T-chart. Step number three, fill in units. Given units on bottom, unknown units on top. Okay. So now I have a T-chart with no units. My given units always comes on the bottom. I always underline my given units, never the numbers. Let's do that. Never the number, only the units. This number will never come down. Grams of chlorine. So underline it, grams of chlorine. And then for the top, that one's going to be mole of chlorine. All right, so then for every 1 mole of chlorine, you're going to get 35 grams of chlorine. So this is just matching. So once I get my units in here, grams of chlorine at the bottom, unknown units at top, now we just fill in numerical values. So the numerical values, when I fill them in, so again, given units at the bottom, unknown units at top. Now I just use this ratio. So 1 mole of chlorine, this one goes with mole of chlorine. This is gram of chlorine, this is mole of chlorine. So the 1 is going to go here. And every time we have mole to something else, the mole is going to get 1. The only time mole will have numbers if it's a mole-to-mole conversion. And then 35 goes with grams chlorine, so 35 goes with gram chlorine. Here's 35. This matches with grams of chlorine. All right, and now we need to execute the math operation. So this is just 2 fractions. So I just consider this 1 fraction, and then this is another fraction. So gram chlorine over gram chlorine, those cancel, and I'm left with this unit, mole of chlorine. And then now we have 70 times 1. That's my numerator. And then 1 times 35 in the denominator. Okay, well that's just going to reduce. So we can reduce that down to 2. So this would be 2 mole Cl. It's too easy. This is too easy. All right, so this one we're going to do it a little bit faster. I'm still following the steps, but I'm just going a little bit faster. All right, so how many grams in 3 moles of O2? It's 958. You know, even if you take the steps, it doesn't take that much time. All right, so let's write out the given information, unknown information. So the given information is 3 mole O2. And then for my unknown information, they want me to find grams. And we're still dealing with O2. We have an equality. So if we go here, I know the oxygen is 16, 15.999, but we're just going to call it 16. All right, so for every 1 mole of oxygen, that's going to be equal to 16 grams. But we don't have 1 mole of oxygen, we have 1 mole of O2. Well, if oxygen is 16, then O2 is 32. And then I can rewrite that as a ratio. 1 mole of O2, that's going to be 32 grams. Okay, so I have the information I need. And now we just follow the steps. Step number 1, rewrite my given and draw my T chart. 3 mole O2, got my T chart. Step number 2, well that was step 2. Step 3, fill in my units. Given units always goes on the bottom. Unknown unit always goes on the top. And then from there, we're just matching. We're going to fill in the numerical values. Step 4, fill in numerical values. The 1 is going to go with mole O2. This is gram O2. This is mole O2. Anytime we're going from moles to another unit, it has to be a 1. This is 32. 32 grams O2, that goes with gram O2. This is just 2 fractions. And then this would just be 1 at the bottom. So 3 times 32, that's 96. Then mole O2 cancel out the gram O2. All right, so those would be the steps that we use for doing our conversion. This will work for any of the stoichiometry, Avogadro's number, molar mass. Next, you'll see we start getting into 2-step problems and 3-step problems. So for molar mass and a mole to mole, those are all going to be 1-step problems. When we start doing grams are given to moles of unknown or grams are given to grams of unknown, that's when we start seeing 3-step problems. All right. So next we have molar mass, Avogadro's number, and molar volume coming up. Stay tuned for that video.